Okay, another standard that you need to know are congruent triangles. And remember, congruent triangles are different than similar triangles because congruent triangles means it's a stronger condition, and all of the theorems for congruent triangles are going to involve sides, as you'll notice. This stands for side, 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 angle, side, angle, 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 side, side, angle, side, and this is hypotenuse leg. We'll see how that works here. Now this, with a proof, you have to take what's given. You're given B is the midpoint of AC in this particular triangle, and if B is the midpoint, then that would lead you to conclude that this AB is equal to BC. So in your flow chart, you would say B is the midpoint of AC, and that leads us to this conclusion that AB, okay, is congruent to BC. So this is given, all right, and this leads us to this fact right there. So that's important to get. Once you know that, you know this is a right triangle, so you've got a couple options here. You can go ahead, this side, this angle, and this side, this is a shared side, would give you an SAS. So simply go like this for the other bubble, angle, or the measure of angle ABD is equal to or congruent to the measure of CBD, okay, equals 90 degrees. So they're both 90 degrees. Then the other thing is that this side is a shared side, BD, shared side. So BD over BD equals 1. That's a good way to show the ratio of the two is equal to 1, means that they're the same side. So now you have S, all three of these things contribute to the fact that triangle ABD is congruent to triangle CBD, and by the SAS theorem. So side, angle, side theorem, and again, if you go back on it, this side here, that angle there is shared, and that side there. If this is 90 degrees, then of course this is 90 degrees, because this straight line theorem, which is that if this is 90 degrees, then this whole thing is 180, then that has to be 90 degrees. So that's a nice proof. Now there are other ways to do it. You can use the hypotenuse leg theorem. So this is proof by SAS. The hypotenuse leg theorem would be like where you go, okay, I've got that B is a midpoint of AB, so B is a midpoint of AC, so that AB and BC are equal. This is a right angle. You suddenly have yourselves two right angle triangles, and you can show that the hypotenuse leg, you've got one leg, you've got a right triangle, and the hypotenuses are going to be equal. So these two, AD and CD, are going to be equal, and you can use the hypotenuse leg theorem to show that, and then prove that these two are congruent. So either way would work, but when you do these proofs, if you're using the bubble flow charts, you have to make sure that each contains a fact written in a precise format, like this, for instance, BD over BD equals 1, shared side. If you have givens, then you have to use those givens to prove or support facts. So in this case, we wrote given, B is the midpoint of AC, and that's the reason why AB is BC, and that's how those work.